Hey everybody, we have an example here where we are going to complete an identity. The directions might not read complete the identity for something like this next time. It could say something like, simplify the given trig expression, or rewrite the given trig expression as a single trigonometric function, something along those lines. And really they're just asking you, use the knowledge that you have to clean this up, and let's go for it. So usually I start by trying to get anything out of the denominator if I can, and then changing everything into sines and cosines panic mode. And while that's fine to do here, it's kind of like gonna waste a little bit of time. So I just want to point out a couple other options. When you have things being squared, especially in a case like this where we have right with one another, sine squared and cosine squared, and they're being added and they're squared, they have to be squared. I can rewrite this sort of like commutative property is going to happen. I'm just going to swap the order of these two terms, okay? So I have sine squared theta plus cosine squared theta plus tangent squared theta. I haven't really done anything. I just reordered the two terms right here, okay? I flip-flopped those two terms. All right, commutative property, they're both positive, nothing to worry about here. Now these two terms I can rewrite using the famous Pythagorean identity, it equals 1, and now I have 1 plus tangent squared theta. While sometimes you're only able to get things down to a sum of two expressions or two terms, we can go further with this one. You should know all three Pythagorean identities, to be honest. It's just more practical. And if you do, you should know that that is equal to secant squared theta, and that would be the end of it. If you are having trouble memorizing it and you only really know this first one, just to go over for the millionth time of my life how we can come up with the other two from just this one, you can get one of them by dividing everything by cosine squared theta. So if I did that, sine squared theta divided by cosine squared theta is tangent squared theta, plus cosine squared divided by cosine squared is 1, equals 1 divided by cosine squared theta is secant squared theta. So there you have it, Pythagorean identity numero dos. And then just let's use as much paper as we can. To get another one, I can divide everything by, can you guess? Sine squared theta. If I do, right, this is a division like this over here, and then the other two dots is actually a colon, like me saying like this is coming after it, like showing you how it's done. So if I divide everything by sine squared divided by sine squared is 1 plus cosine squared over sine squared is cotangent squared theta, and 1 divided by sine squared is cosecant squared theta. So there you have it, Pythagorean identity numero 3. There you have it. Okay, so that's the third one, and here's the second. Now, obviously, all of this is quite impossible if you don't know your reciprocal identities, right? Also, you would want to make sure, I have one last doofy thing since we're kind of short, not even 4 minutes yet. So one more thing that you could kind of say to yourself maybe is tan and cotan can be with someone, can positivity adding, be with someone, be with one. Secant and cosecant can't be with anyone. If the one is on the same side as the positive secant or cosecant, it's going to be a -1, so that's your negative, your can't. So if that's helpful, you're welcome. If you are ready for the next one, go ahead, click through for the next example. If you feel smart right now, please go ahead and give the video a thumbs up. If you are confused and SOS need help, go ahead, give the video a thumbs down. But click through for the next, look for more videos, more examples. And if you did it differently and you have a suggestion, leave that in the comment section down below. Hope you're feeling smarter. Adios.